Hey guys, let's look at this question. You'll find this question on 2012 past paper. It is question 2. It is about the photoelectric effect, which we have just covered. And you can pause the video to read the question a little bit. Let's look at it. So we're given the wavelength of some light, and we want to calculate the energy of this light, or for this light. Okay, let's see what we do here. To calculate the energy for photon of light, we use this formula. E is going to be equal to h times f. This E is the energy we want here, and h is a constant. F is the frequency of a light. So we want to know the frequency of this light, but we don't know that, but we know the wavelength of it. Now there is this strong connection between the wavelength and frequency, which is c is equal to f times lambda wavelength. C is the speed of light. Speed of light is equal to frequency of that light and the wavelength of that light. See, there's the f here, c is a constant, or lambda is given, so we can calculate the f. So we can rearrange this. So f is going to be equal to c over lambda. And then we want to plug this new thing into here, okay? Yeah. So we can change the energy equation into something like this. And now we didn't change anything, okay? We just rearrange things. So let's use maybe a different color to fill in the blanks to write here. So we have E is going to be equal to H times F, and we have C is going to be equal to F times lambda. By rearranging this second one, we have F is going to be C over lambda. And then we want to plug this equation or formula into here. We have E is going to be equal to H times C over lambda. And since this lambda is in the meter of in the unit of meter, so we're using the international units here. So your energy should have the unit of joules in the end. Now all we have to do is to plug in some numbers, right? H is 6.63 times 10 to the power of negative 34 times your C is 3 times 10 to the power of 8, and your lambda is given. It is 5.89 times 10 to the power of negative 7, and we can use our calculator to do this. Okay, yeah, I think we should use the brackets. 6.63 times 10 to the power of negative 34 times 3 times 10 to the power of 8, and it is divided by 5.89 times 10 to the power of negative 7. So this should be our final result. Since the wavelength is given in this format, like 5.89 in 2 decimal places, so maybe we want to correct our final answer to 2 decimal places too. So it's going to be 3.38, right? Let's come back. Should be 3.38 times 10 to the power of negative 19 joules. So energy is, we can write it here. Yeah, so this is how we do this question.